Hi, boys and girls. Let me first give a shout out to my 6-day weekers. You know who you are and what I mean. Thank you for your hard work and your dedication. It will pay off. All right, dilation. Dilation changes the size of the shape without changing the shape. So for example, a lot of you probably have heard dilate or dilation before. If you go to the eye doctor, they'll dilate your eyes. We're going to try this tomorrow in class, but if you were to try it right now and look in a mirror, so go into the bathroom, look at your eyes in the mirror, and then turn the light off, turn the light back on again, and your eyes will get bigger and get smaller again. That's called dilating. When you enlarge a photograph or use a copy machine to reduce a map, you are making dilation. So a dilation is a change in the size. The shape stays exactly the same, but the size changes. So what does that mean that dilations are not? Dilations are not congruent. This is the only transformation that does not preserve congruence. Enlarge means to make a shape bigger, and then reduce means to make a shape smaller. The scale factor, and it's a vocabulary word, tells you how much something is enlarged or reduced. You should have used scale factor last year when you talked about similar figures. Dilations, I don't want that. It's not going to let me undo it now. All right, so dilations produce similar figures. Look at these pictures below. Look at our star here. So this is our original star right here on the left, and we're dilating it by a scale factor of 75%, or we can say the scale factor is 3/4 or 0.75. What happened to the star? The star got smaller. Now we're going to dilate the image with a scale factor of 150%, which means the scale factor is 1.5, and what happens? The star got bigger. Suppose we dilate it with a scale factor of 100%. The scale factor is 1. Well, what happened? It's the exact same size, so it didn't change at all. So now this is congruent. When the scale factor is just 1, that means that it stays the same size. When it was 75%, it got smaller because the scale factor was less than 1. When it was 150%, it got bigger because the scale factor was greater than 1. When the scale factor is 1, because all you're doing is multiplying, anything times 1 is itself. Okay, so scale factor smaller than 1 gets smaller, bigger than 1 then gets bigger, and when it's 1, it stays the exact same size. All right, so this is that same chart we looked at before. Excuse me. So when we have translation, rotation, reflection, we change the shape. We change the position but not the shape, and these are all congruent. And then when we change the size of a shape, we have a dilation, and this is not congruent. If you can read my little chicken scratch there. So you should all have this note page with the same notes that we've taken on the other 3 transformations. So make sure you have this. If you don't, write them on another piece of paper, because this is how I'm going to know that you watched this video. Okay, you can take it out, and let's get ready to copy. All right, so the figure stretches or shrinks. Stretches or shrinks with respect to a fixed point. Our fixed point is going to be the origin, it's going to be 0, 0. And the rule is we do x, y, and then we do k times x, k times y, where k is the scale factor. So in this rule, we are multiplying. When we were adding or subtracting, that was a translation. If k is bigger than 1, we stretch. If k is less than 1, we shrink. I can't stand this pen. Okay, so the figure stretches or shrinks with respect to a fixed point. We are always using the origin. The rule is take your original x, y, and we map it to k times x, k times y. K is the scale factor. When you have a K bigger than 1, you're stretching, less than 1, you're shrinking. All right, let's try an example. Let's use the scale factor of 2. So point A is over here at 2, 3. So what you're doing now is you're going to take your xy, and you're going to do 2 times x and 2 times y. 2 times 2 is 4. 2 times 3 is 6. So this is A prime. B prime. 3 times 2 is 6. 2 times 1 is 2. And C prime. 2 times 1 is 2. 2 times 2 is 4. Then we can plot. So we have 4, 6. Okay, A prime. B prime is 6, 2. And C prime is 2, 4. Hopefully I put these all in the right spots. That's a C prime there. Okay. Yes, the location moved, but that's only because it got bigger. Okay, so all you're doing is making the side lengths longer by a scale factor of 2. And this is similar now, not congruent. And all right, example 2. Draw the image of a dilation having a scale factor of 0.5, which is the same as 1/2. So our xy is going to 0.5x, 0.5y. So you're multiplying each by 1/2. So that's m prime, not a prime. Oh, why doesn't it let me erase? There we go. So m prime is going to be at -3, -2. A prime is -1, -2. T prime is -1, -3. And H prime is -3, -3, because we divide it both by 2 or multiply them each by 1/2. So we have -3, -2, -1, -2, okay. M prime, A prime, the T prime is -1, -3, and H prime is -3, -3. Notice how this time our rectangle got smaller. We shrunk because our scale factor was less than 1. All right, the pre-image and the image are similar figures, is what I started to say before. Similar, which means the same size. Different shape. The corresponding angles, and only the angles, are congruent. And the corresponding sides are parallel and proportional in length. All right, make sure you have these notes. We'll glue them into our next page in our INB. We will do the practice in class tomorrow. If you want to try the practice now, you can go ahead and do so. Have a good night.